Hey everybody, this is Gregory from Dapp University. Welcome back to the multi-part tutorial where I'm showing you how to create your own cryptocurrency and build your own ICO on the Ethereum blockchain. This is the next video in the series where we'll be continuing to build out the token sale contract. In the last video, we created the token sale contract and we created the constructor. And in this video, we're actually going to build out the functionality that allows, an account to purchase tokens. So if you haven't seen the previous videos, be sure to check those out and subscribe to the channel so that you can see the rest of the videos in this tutorial whenever they come out. And if they have already come out, you can just check the link at the end of this video or watch the next video in the playlist. Now, if you're picking up at this point in the tutorial, you've got the code that you've written so far, and if you want to just download the code at this point in the tutorial, you can check out the link to GitHub in the description below. I'll put a link to the latest commit. And we can also just check that we have Ganache running. This is our local blockchain. It's running. You can minimize that. So let's jump into, building out the rest of our contract. This is our token sale at this point. We can go ahead and sketch out something for, buying tokens. We can reference this little text file that I showed you in the last video. In the last video, we set the token price and we assigned an admin inside the constructor. And we also, got access to the contract. And in this video, we want to buy some tokens. And we're also going to, provision the number of tokens to the token sale. So we can, sketch out something for buying the tokens here. Let's say function, buy tokens. And we'll pass in an unsigned integer of the number of tokens. Let's say public. We want this visibility to be public because we want people to actually purchase the tokens. We also must declare this payable. And I'll explain that in a second. But this is our starting point. So here's our function for buying tokens. We want it to be public because we want, to expose this to the public interface. When we build out our client-side website, we want to call this buy tokens function. We want to, allow someone to pass in the number of tokens that they want. And we want this function to be payable because we want someone to be able to send Ether via transaction with this function. And that's what we have to do for all functions in Solidity that want to send Ether like this. We declare it payable. Now let's go ahead and write a test so we can, check for the functionality here. So let's do this. We'll add a new test. We'll say it, facilitates token buying. All right, we'll pass this a function. Okay. Again, I'm going to give it some space here so we can see. And I'm going to do the same thing, that we do everywhere else. I'm going to copy this and paste it. Okay. And inside of here, the first thing that I want to test for is that that this really just keeps track of how many tokens were sold. That'll be kind of an easy first step that we can test for. So let's actually sketch out what we want. We want to keep track of the number of tokens sold. We'll just simplify this. We will emit a sell event. We'll say trigger. We want to basically require that the number of tokens, well, basically we want to, the amount they're buying the tokens for, we want to ensure that that's the same amount as the token price. We want to kind of require that there are enough tokens in the contract For example, if this contract only has 100 tokens and I try to buy 1,000, we want to prevent that. We want to require that a transfer is successful. And this is where we'll actually contract, or this is where we'll actually see that from our contract. All right, so let's work on this first. Let's just do something simple and keep track of the number of tokens sold. This is actually going to be somewhat of a complex function, so this will take a minute, but let's do the easy part first. So we can do that like this. We can just say return Dapp token sale. Well, we've already done this. Let's do this. Keep track of the instance, just like we did in other cases. And then we can return token sale instance. You want to buy tokens. We can say the number of tokens. And let's add some function metadata here. This is going to be this is going to correspond to msg.sender. And this will be the buyer. And the value is going to be the amount of ether that we're sending, expressed in way, when we call this function. So let me explain that. Whenever we call this function, whenever we purchase tokens, we can specify the number of tokens we want to buy. But remember that Solidity functions have some metadata that we can use, and that function metadata is going to require two things. One, the account that is calling this function, and two, it's going to have to know the amount of ether expressed in way that they're sending, right? So when we call this, we actually have to send some ether. That's why this is payable. So we can do that like this by expressing the value here. So how do we get the value? Let's just say value. Well, we can get the value as the number of tokens right here multiplied by the token price that we declared here. This is going to be the value in way. So think about that for a second. The amount of way that we need to send in this function is going to be the number of tokens we want to buy times the token price. Make sense? This is how many way. This is how much one token costs, and if we want, 2 tokens or 10 tokens, so we have to multiply 10 times the token price to get the amount of way that we want to send with this function. And this buyer is just going to be the person or the account that's purchasing the tokens, and this is the number of tokens. So we can declare the number of tokens equal to 10, right? So we got number of tokens, the value, number of tokens times the token price, which is up here. And so that's how we're going to buy tokens. So whenever that happens, we will let's check the amount. Well, first of all, this is going to be a receipt because we're creating a transaction here. And we'll dig into the logs later, but we'll skip that for now. We'll say return token sale instance. And we'll check for the tokens sold. All right. We can also do this. And we'll check that the, sorry, not receipt, the amount. We'll assert that the amount to number is equal to the number of tokens. All right, so that makes sense. So basically we want to buy some tokens, and whenever that happens, we want to check for the number of tokens sold, because that's the functionality we want to build out first. And we want to ensure that the number of tokens sold is the same as the amount of tokens we just bought. So we can run our tests. Oops. All right. See, this is failing. Buyer is not defined, so I forgot to do that in a test. Sorry about that. Let's tell you what. Let's keep track of the buyer up here. We'll say for our buyer accounts 1. And actually, let's go ahead and refactor this a little bit. Let's keep track of the admin. Well, we'll wait on that for now. Here's the buyer. So, yeah, we want to buy the tokens, and here's our buyer. Here's the value. Here's the number of tokens. Let's run that test again. All right, token sell instance token sold is not a function. That's what we expect. So let's implement that. We want to keep track of the number of total tokens. The total of tokens sold, pardon me. We'll do that with a state variable. We'll say an unsigned integer. We want to make this public so that we can get a function that we're using in our tests. All right, tokens sold. So we can increment that number like this. Oops. Use the increment operator, and we'll just use this variable that we're passing in. All right, it's pretty straightforward. We're just increasing this number by this number. This will start out as 0. So let's run our test, see if it passes. All right, number of tokens is not defined. Let's see here. This is just a little error in our spec, so let's refactor a little bit. Now that y'all can see how this works, let's actually move this back over here. We'll do number of tokens is equal to the value. There's no real need to keep track of value here. You can kind of see it expressed here, the number of tokens times the token price. Clear that out. And let's actually declare this variable before we run our test so we don't have this problem. We'll just say our number of tokens. All right. Save that, run our test again. All right. So it looks like Ganache has crashed. We will restart that. If you all see this error, cannot connect to RPC instance or your Ethereum client, probably your Ganache instance has crashed. So we will relaunch that. All right, we're back to normal. Let's try to run our tests. Boom, it passes. All right, so we have successfully incremented the number of tokens like this. Let's kind of work on some more easy stuff before we get into the hard stuff. Let's actually trigger this sell event. We can write this in our test. we'll, dig into this transaction receipt like we did in previous tests. Remember, we kind of checked for an event, right? We dig into the logs. We'll do the same kind of thing here. So I'm going to just paste in some code so that we don't have to laboriously, code this out. And I'll let you all see that. And like I said, you can download this code if you need to. So I'm taking the receipt, and I am looking at the logs to see that there is one event. And I'm also trying to check, here, I'll close this so you can see. I'm trying to check that it's the sell event and that it has a buyer. It logs the account that purchased the tokens and an amount. So it's going to log the number of tokens purchased. So we're going to check for that sell event. We'll run our tests. All right, it didn't get any events, which is what we expect, so we can go back to our contract, and we'll trigger an event. So before we trigger, we actually need to declare an event. We'll do that like this. Oops. All right, and if you check our tests, we said we want to keep track of a buyer and an amount. So we'll say address, buyer, and unsigned integer, amount. Okay, and let's trigger this event. So sell. So who's going to be the buyer in this case? Well, the buyer, since this function is payable, is going to be the account that is calling this function. So the buyer is going to be msg.sender. All right. And we're going to list the amount of tokens that they purchased. And this is not going to be the value that they were sending. It's going to be the number of tokens here. All right. And we can see that that's what we checked for in our test. Save that, run our test. All right, looks like we have a syntax error here. It's just a little typo. My fault. I forgot to capitalize the T in tokens. All right, boom, it passes. So we have successfully triggered this sell event. Okay. So now we'll get into the kind of hard part of this test. This is going to be these 3 steps. We'll kind of work our way through the easier part and then kind of get to these parts, which are a little trickier. So first, let's just check that the value is going to be equal to the number of tokens that they're trying to purchase. Okay, so we can just check to see if we can try to buy some tokens for a value that's different from what we're sending. We'll do that like this. We'll just say try to buy tokens different from the ether value. We'll say return token sale, buy tokens. We'll say number of tokens. This is the variable that we used here. Let's just copy this. We'll pass in some function metadata to specify the buyer. And so here's what we're going to test for. Now, this would always give us, the number of tokens times the token price. This is how much, way we want to send, right? Remember, way is just the smallest denomination of ether. It's the smallest subdivision. So the token price is this many way. It's a lot. And we multiply that by the number of tokens to get the amount of way that we actually want to send, right? So we multiplied that by, I believe, 10 in our last example. So let's try to rip off our token sale. Let's just try to say, hey, we want to try to buy, 10 tokens for 1 way, which would be an incredibly small amount, a very, 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 very tiny amount of ether, right? So this is like what we really want to guard against is someone underpaying for our tokens. I mean, we really want to guard against overpaying, right? Because we don't want people to get ripped off themselves, but we really don't want anyone to rip us off. So we will, try to cheat the system here. So we will check for that. And just like our other examples, we will check for a failure. You do assert fail. And then try to catch that. We'll say function error. And we will just check that the error message has revert. We'll say revert. Sorry. 0. And we'll say msg.value must equal number, of tokens in way. Okay, I'll explain msg.value here in a minute, but let's run the test first. All right, so it did not get any kind of failure. So let's make it fail. So this is what we want to fill in. We want to require that the value is equal to the number of tokens. So essentially, remember, we're trying to prevent someone from underpaying or really overpaying for this amount, right? So how we would do this is say require that the MSG value is equal to, we would say the number of tokens times the token price. Now, this is not actually the code that we're going to use. I'm going to change this in a second, so don't get too attached. Let's kind of do this step by step. So first, msg.value is some more metadata that we're going to get when this function is called. Remember, we have msg.sender. Remember, msg is our global variable. It's got some data that we have access to. msg.value is the amount of way that this function is sending. We can see that here, msg.value. And we want to say that that's equal to how much this is actually going to cost, right? We did the number of tokens times the token price, which is what we did in our test. Number of tokens times the token price. So that's what we want to require. We want to require that that's equal. Now this looks nice, but we don't just want to multiply these things, right? Because this could be this could be really any value, right? We want to do some safe math here. So I'm actually going to create a function that handles this multiplication for us because we don't want to just use this by itself. And I'm going to kind of reference an external library. So we want to create like a multiply function, right? And we actually want to call it here. All right, so we want to build this multiply function. And I'm actually going to reference an external library without pulling the entire thing in. I'll kind of just give you guys an example here. I'll introduce you to DSMath. So this is basically an external library that allows you to do arithmetic operations or arithmetic operations safely in Solidity. So it allows you to do things like add, subtract, multiply, divide, etc., without it allows you to do it safely without causing any problems in your contract code. So I'm going to look in the source here. and look at math. This is the library we would normally include, but I didn't want to add another dependency to the project, so we'll just kind of reference how their multiply function works, and we'll do something very similar. So y'all can check out this library more just by going to Dapp Hub's organization, looking at DSMath. So I'll close that. And let's implement the multiply function. We'll do it like this. We'll take an unsigned integer. Oops. All right. So I'm not going to go into this too in depth, but this is pretty similar to what we saw in DSMath. Basically just takes two numbers that you want to multiply by, and it does this safely in Solidity, and it returns the value. Now, I'll explain a couple things about this function. The internal visibility means that this is only internal inside the contract. It can't be called externally. Pure just means that it's not actually creating any transactions. It's not reading or writing data from the blockchain. It's just a pure function. You might be familiar with that concept from other programming languages. It takes in a function of the same data type and returns the same data type. Yeah, so that's what this function does, and we're going to use it here. So let's run our test, see if an error occurs. Boom, it passes. Okay, so we have successfully required that we're buying the tokens for the correct amount. And the next thing we want to do is build out these next two steps. We want to make sure that the contract actually has enough tokens before we allow you to purchase some. And that's going to require a little bit of setup inside of our test. So let's go ahead and do that. So in order to require that the contract has enough tokens, we need to actually provision some tokens to the contract. If you remember, that was one of the kind of steps that I listed here. We want to provision some tokens to the token sale contract. So just to recap, just like external accounts, like wallets can have tokens, so can a smart contract, and that's what we want to do here. We want to give this token sale contract some tokens because it has an address, and we can, add some to this balance of function inside of our token contract. We basically want to check this balance of and use a contract address here instead of an external account. So we'll do that by transferring some tokens. Actually, I'll open that back up. We'll do that by transferring some tokens to our smart contract instead of an account. The basic idea is, if there are, 1 million Dapp tokens at the total supply, we want to take some amount of that total supply and transfer them to the token sale contract instead of another person, and we want to essentially sell those. All right, so there's a few setup steps here in order to kind of modify this test and make it do what we need to. First, I'm going to actually import the token contract. So let's do that. We'll call this Dapp token. All right, we'll keep track of that. And I'm going to deploy that first. So let's do this. let's do it like this. Call this Dapp token, deployed, and let's keep track of the token instance. So do Dapp token deployed, then instance, and this will say token instance, and we'll just make a note here. Say grab token instance first. Okay. And then we can do Dapp token sale deployed. And this is going to return a promise. So we can specify the return value here. And we can, do this. Oops. And say the instance here. Actually. And then, we will then grab token sale instance. Okay. So now we have access to our Dapp token instance inside of our test, and we have access to our token sale instance. So we have two contracts that we want to interact with. And before we start, we're gonna continue modifying this kind of test chain, and we'll do a couple more setup steps first. So we have access to the token instance. Then we have access to the token sale instance. And next we want to provision some tokens. So essentially we want to take some of the total supply and give it to this token contract, right? And remember the total supply when we deployed the contract was, I think 1 million, right? 1 million tokens. And we want to take some of those 1 million tokens and give them to the token sale contract, right? But who has the 1 million tokens, right? Who has the 1 million tokens whenever this is deployed? Well, if you remember, inside of our Dapp token contract in the constructor, we assigned all of the initial supply to the person who deployed the contract, right? And in Ganache and in this environment, this defaults to the first account in the list, which is this account right here. So if you're following me, MSG.sender, in the case of this deployment, is the person who has all 1 million Dapp tokens presently whenever we deploy this contract in our test case. So what we want to do is transfer some number of tokens from that account to our token sale contract, right? And let's just say that that person, since it's going to be, the first account in the list, is also going to be the admin. So we'll do that here, admin. Oops, 0. All right. And how many tokens do we want to provision, right? So we said we had 1 million tokens. So let's do 75% of them. So we'll say tokens available. 750,000. It's going to be 75% of 1 million. So in this step, we want to provision 75% of all tokens to the token sale. All right. So again, that's going back to this kind of first step. We want to provision some tokens to the token sale contract. We're taking 75% of the total supply sorry, the total supply, 75% of the total supply, which currently all belongs to the first account in the list, right? This is the admin. This is account 0. Taking 75% of all of those and transferring them to the token sale. So we can do that like this. Return. Instance transfer. Remember, this is the function inside here. Move this over here. Oops, sorry. This is our transfer function. We're going to transfer token sale instance. We're going to say we'll transfer, all of these tokens that are going to be available in the token sale, 75%. Tokens available. And we will do this from the admin. Okay. So the admin is going to be the first account in the list. This is who has all 1 million tokens so far. And we're going to say, hey, admin is going to call this transfer function, and it's going to transfer not to an external address, but the contract address. And we're going to, transfer 75%, which is going to be all of the tokens available in the token sale. So this is really just a setup step to kind of give our token sale some tokens to work with. And once we've done that, we can just kind of close this out by, and function. This is going to be a receipt because this is a transaction. Oops. We'll just close that for now. Okay. So that kind of gets us up to speed. It gives us some setup steps. So recap, we're getting the token instance, getting the token sale instance, and we're giving the token sale instance 75% of all tokens in existence to start out with. And now we want to try to actually buy some tokens so that we can trigger this right here. We want to require that the contract has enough tokens. So we want to try to buy more tokens than the contract actually has. So if the contract currently has 750,000, we can try to buy some, obscenely high number, and we want to require that this fails. Okay, and we can do that like this. Okay, so let's add a test to see that you can, try to purchase more tokens than are available. So let's do this. We'll just kind of copy this. Like this. We're going to check for another failure. And we'll try to, see. We're going to try to purchase, more tokens than are available in the contract. So I've just copied a, valid value here. We're going to buy the tokens for the correct price, and this will be from the buyer. And let's say the number of tokens is 800,000. Okay, that's more than we have, right? It should be 750,000. So I'm actually going to just test this in isolation. So let's comment this out for a second, just to ensure that we're going for the right failure here. Let's take out all our other require code here. And we'll do truffle tests. Okay, looks like Ganache has crashed, so we'll restart that. All right, Ganache is running again. All right. So our assertion didn't work. Well, because we haven't, coded that yet. So let's actually change the message here. So that's what we want to implement. So we want to require that the token contract balance is the balance of the token sale is greater than the number of tokens that we're trying to buy. We always want to make sure that there are enough tokens whenever we're doing this. So we can do that like this. Token contract, right? We've kept track of this up here. Token contract, balance of. Remember, that's how we check for the number of tokens that exist. That's in our interface here. Let's see, balance of. And we want to say, what is the balance of this smart contract, this token sale contract? Well, in Solidity, we do that like this. We just pass in this as a reference to the smart contract. We say it's greater than or equal to the number of tokens. Okay? And that's how we actually code this requirement. So we want to check that there are enough tokens owned by this smart contract whenever we're trying to purchase them. Run our test. Boom, it passes. All right, so I'm going to activate this and kill this and make all our tests live. Run them again, see if it works. Boom, still passes. All right, so we're getting close here. We've done a lot of setup steps in order to facilitate token buying. And the last thing we want to do is actually transfer the tokens. So we'll write the tests first. Go into our test file. And let's try to check to see that some tokens were actually transferred when we triggered, this successful transaction, right? We already bought the tokens. We've already done this in our test. The buyer has bought them. We want to check the balance of the buyer, and we want to check the balance of the token sale. So we want to see that the balance of the buyer went up. We want to see that the balance of the token sale went down. So we can do that like this. First we'll go, let's do it here. We'll say, let's do this. We'll return the token instance, balance of. Let's check the token sale instance first. All right. And we can just copy this. We'll say it's a balance. And we can assert that the balance to number is equal to, the amount of tokens that they actually bought, which was, I believe, 10. Let's see here. Yeah, 10. So let's check for the tokens available minus tokens bought minus the number of tokens. All right. And let's also check that, let's check that actually worked. So we're going to run our test. All right, failed. So in addition to, the balance of the token sale instance, let's actually go on before, and let's return the balance of the buyer. we'll do this same thing here. We can check that the balance is equal to the number of tokens. All right. So that's failing. Let's go to our test and actually implement that. So we'll go to our token sale and let's require a successful transaction. And we're going to do this inside of require because we want this to revert if it doesn't happen. We'll say require that the token contract transfer, that's the function from the token contract, msg.sender. All right, so let's look at that. The transfer function takes a to address. This is who we're sending the tokens to, and this is the the value. So we're calling transfer. We're sending the tokens to the sender of this function, which is the buyer in this case, and we're buying tokens. We're calling transfer on our token contract, and we are specifying the number of tokens we want to buy. So this is the actual buy functionality. So we can run that test and see if it passes. All right. So let's see, it did not add the receiving account. All right, it didn't actually give him any tokens. So let's see what's going on there. I think this is just another case where we need to rerun our tests. All right, it worked. So we can see that we've got a full function here. This is the ability to buy tokens, and it's fully tested. So this is going to allow an account to call this function. They're going to pass in the number of tokens that they want. They'll send the value with their wallet, which we'll see on the client side. And yeah, this is fully robust. It's got all these checks to make sure that we're buying for the right amount, that we have enough tokens, and that the transfer is successful. And this will keep track of the number of tokens sold, and it will emit a sell event. And we've got all the tests for this. All right, so that's it, guys. That's the end of this video. We're almost finished developing our token sale contract. We've just got one more bit of functionality that we'll add in the next video. So be sure to subscribe to the channel if you haven't already to catch that video when it comes out, and turn on notifications with the bell below. And if it's already come out, you can just click the link at the end of this video or just find the next video in the playlist. And until then, thanks for watching Dapp University.